Hey guys, welcome back. Today we're going to be unboxing, setting up, and doing our first prints on the Creality CR-6 SE. All right, let's unpack this guy. So the CR-6 SE was Creality's first Kickstarter, so you may have seen it there already. It was released a little bit ago, and this will be my first time taking an in-person look at it. So we've got a small spool of PLA. We've got our screen, spool holder, power cord, handle. Everything has this nice little pocket that it slides into in the packaging. Some nuts and bolts. Oh. Careful you don't throw something away. All right, the other part of the spool holder. The uprights, you'll notice fully assembled, so that's going to speed this along. You know, when you compare it to something like a full kit printer like a Ender 3 or something, it takes a little bit longer to build. All right, the base, and there's some heft to this base for sure. All right, so here's all the pieces we're dealing with. And as I mentioned, it's going to be a lot quicker than an Ender because the entire upright assembly here is already pre-assembled from the factory. I opened the manual and took a quick look and realized that we didn't have any tools. But then I remembered, much like on the Ender 3 V2, they have a drawer in the front here. And this drawer nicely contains all of our assembly tools, our spatula, including this interesting scraper. So yeah, don't fret if you don't have the little baggie with your tools, that's where they are. We also got some stickers and swag. Let's just go through actually part by part and just look at what's in here. So we have a nozzle cleaning little needle. We have the world's smallest pair of flush cutters, or snips. Very small, but obviously to fit in this package, and it is actually cut out to fit every piece specifically, which is kind of nice, so they're not sloshing around. But if you so chose to have full-size tools, you could just take the foam out and fit it a lot better. So USB micro SD/SD adapter, and then some spare nozzles. Looks like there's a coupler in there and a couple little clips to lock in the coupler onto the Bowden tube. We have a dedicated tool. This is probably going to fit on the nozzle, but it might fit some other stuff as well. Likely just a nozzle removal and installation tool. This is something that I do myself already with my printers. I have a dedicated mini ratchet that I use for nozzle changes. Standard Allen keys, a wrench, and a full-size SD card. So, where are we here? There, we got a little sticker on the front here showing you which way to install your SD card. It says this side up, so it's showing you pins to the sky. So it goes in like that. Standard press click. So that's our tools strewn all over the table at this point. But we're going to install the upright onto the base. So there are two areas here. They're actually notched out, like milled out of the legs here, where this will line up with and then bolt through the base. So as you lay this on top there, it should slide right into these little milled out grooves. Don't be afraid to kind of manhandle it to get it lined up and in the grooves properly. And then we're going to bolt it through the base from the bottom up with these M5, I think they're M5 by 25 bolts. Whoop, grab that later. There's only so many bolts in this kit since it's all pre-assembled. It's pretty obvious what goes where. These big black ones here are what we're going to use to bolt up through. Now, on some printers, I'll tip them on their side. On this one, I'm just going to hang it over the back of the table here, very carefully, to give me access to the holes on the bottom, and then screw it in through these. All right, so I've got the uprights installed. They're tight. I'm just going to attach some of these loose wires to where they go. So this one is obviously going to go up into this little daughter board here on the side. So everything on the uprights here connects up to here, and it's got a little key on it, so it only goes in one way. And this is currently at the very top, so that's as extended as it's going to be. And then the other piece here is going to go to another daughter board right here. And that's going to feed things like the hot end, heating up, the auto bed leveling sensor, the fans, etc. Pry these little arms out. There we go, nice and secure. And this should probably go underneath the rail, I would think. There's not a whole lot of wire management stuff here. So yeah, I'm gonna place this underneath here. Let's lower this a little bit. So I'll probably end up zip tying this to the Bowden tube. I'll look at what I've done here. Wow, that was noisy. Okay. So I just use this little clip here and attach that there. We've got tons and tons of slack. Again, this is all the way extended far away, so we can actually pull some of the slack back there like that. And if we so choose, we can zip tie this to the Bowden tube just to keep it extra neat and tidy. While we've got the back here, you'll notice a few things. Departure from some of the other small Creality printers like the Ender 3, Ender 3 Pro, etc. We have dual Z-axis lead screws. Not only that, they are synchronized by a belt at the top. So that enables a few things. You don't have to worry about it sagging on one side and getting kind of off kilter, especially when the machine is off or when you're doing maintenance, or if you're pressing on something, it can kind of get out of whack. But also when you're manually moving the gantry like I did earlier to route this cable, I can actually just spin one and it's going to automatically spin the other as well. So that makes that a little bit easier. I'm curious if they're driving both of these by one driver. I would suspect so, running them both in parallel. Anyway, so I actually don't need to zip tie anything. There's these little clips here. They're like twisted pinch clip type things. So I can use them to secure the cable to the Bowden tube. There's actually 3 of them that are pre-installed on here. So just for the sake of it, I'll use all 3. That's actually going to be, probably annoy me a little bit. I'd want these to be securely fastened to each other. You know, it doesn't have to be super tight. You don't want to pinch any of the wires for sure if you're using zip ties. And I've seen that happen in the shop here. Customers have brought them in and actually pinched the wire and it no longer has connectivity to the end. Causes all kinds of random issues. But I don't like them, being super loosely coupled like this, if you will, just a little bit more snug. So I might change that out later. Since we're looking at the back here, there is the power selector. So make sure that you have it set to 110 or 220. They have 115 and 230, but you get the gist. Especially if you are in a region where your power is 220 or 230. If you have this set to 110 and you plug it in, you're going to fry at least the power supply. So set that correctly. Ours is currently not set correctly. So I'll use whatever I have handy here and just flick it. I'm not going to use that. I'm going to use whatever I have handy here and just flick it until you see 115. And it's also got a sticker that shows you which side is which. For us, being 110, 120, worst thing that's going to happen if we have it set to 230 is it's just not going to turn on. And we have a strain relief and a beefy cord for the heated bed. So it's nice to see that it's a thicker gauge cord because they're probably running a decent amount of current. I'm not exactly sure how many watts the bed is, but being a 24 volt system, watts equals volts times amps, so you can figure out what the amperage is that's coming down that wire, and having a beefy wire gives you some headroom so that wire doesn't heat up with your amperage you're pushing. And a nice strain relief, not just to the bed, but an actual rubber strain relief boot, which should stop that from having any stress fractures or anything there. And since we're looking at the back, let's connect what's left here. They've taped them down to the control box there. Cable for the Z motor. It's a little bit tricky to get at. Move the bed forward. It's also keyed, it goes in one way, and I'm just going to tuck the extra wire back into the control box so it doesn't get caught on anything. And once more for the other side. Okay, so while we're back here, we have a filament runout sensor right here, securely affixed, not a little press fit clip, which is nice, and that feeds into the extruder. It's kind of nice, instead of it being like a spring-loaded lever that you have to keep tension on as you're shoving stuff in, you can actually unlock it, feed it through, and then lock it down. I'll have to double check the manual. I forget if this is a dual drive gear unit or a single drive gear, dual drive gear, kind of like a Bondtech style extruder. But this is kind of a nice mechanism, nice quality of life thing. As we spin it around, we've got the inlet for the power supply. So this is where your cord will plug in. Interesting that it's on the side. I would like to have this at the back, especially if you have a couple of these on a desk and the cables all come out the back. It's a lot easier than coming out the side for me anyway. But now I'm just being picky. Flip it around to the front. So on the side here, we have a nice belt tensioning mechanism. If you think back to the Ender 3, you have to apply pressure and use a wrench to tighten it. So you've just got the standard screw and a similar mechanism on the Y belt to properly tension that. That's actually quite loose. There we go. Better. We already touched on the SD card, and you have a micro USB on the front as well if you want to tether to the printer and print that way instead of through USB. On the bed, I don't know if you can see underneath here, there's a pretty beefy undercarriage that the bed rides on, and you'll notice that there are no wheels, right? We're not doing any manual bed leveling. So ideally from the factory, the Y rail and the bed assembly is level with the base and perpendicular to the uprights, at least close enough. And our auto bed leveling will take that last little bit into account and get us perfectly level. So we also have one more cable here that's taped down. This is going to be for the screen that we haven't installed yet. And on this side, we have another cable, and this is for the Z end stop. So what's interesting is even though they have auto bed leveling probe of sorts, they're not using it for homing. So for homing, that is still handled by this optical end stop here. So let's connect that cable. It locks in there with a nice click. And for those of you that don't know, there's essentially an LED that's sensing if anything is breaking the path between it, kind of like your garage door would have. And as this little flag comes down and breaks that, it knows that that's zeroed out. So the location of this flag, the location of this have to be very specific so that it knows that that's exactly where home is. There's no play in either of these. There's no slots or anything. It's all pre-drilled and pre-assembled. So let's hope that's all bang on. One last thing, just since we're looking at the front, is the bed release clips. So they're these nice swing out levers with a little rubber tab on them. Nice and easy, smooth mechanism. And then you'll lift the bed and then slide it out the front. So on the back of the bed, you still have these friction clips that are just like little spring steel kind of clips. And we have, of course, the protective film on the Creality textured bed that we've seen many, many times. I'm interested to see how well the auto bed leveling works on a glass surface. Unlike something like a BL Touch that uses a probe to physically touch the bed, or an inductive or capacitive probe that sense metals or the surface, they're using an infrared or optical sensor to do their auto bed leveling. If you've ever used like a laser temperature thermometer or something, you'll know that it reflects off of shiny surfaces and you can't get an accurate reading of that surface. And being that this is optical as well on an angle, I'd wonder if reflections off the surface would have any impact in that, especially if you switch this out for some other maybe shinier surface, maybe it's PEI or standard non-textured glass. With any luck, I've actually connected everything. Just give it one last look around. We'll find out soon enough. And so let's install the screen. So the screen, kind of like it did on the Ender series, just bolts into the front of the one leg here. And it's going to use 2 of these silver bolts to attach. The holes are already pre-tapped in there. And just to make my life easier, I'm going to connect the cable into the back here. You can obviously do it after you've assembled it, but rather than having to gawk underneath, a little bit easier. So now we're going to install the spool holder. So there's 2 parts to that, and initially, I've seen these before on lots of Creality printers, and I thought I had lost the other little nut that attaches this to the spool holder. But that's built right into the hole here. So they've got little notches, and it's like a 1/4 turn, and it locks that in. And this is kind of interesting. It's got a hinge on it. It's pretty simple. We hook it on the extrusion right there, and just press down. And we can still slide it forward and back if we need to adjust it. You can also put it on the back side, it says in the manual. I'm not sure that I'd do that. So I'm gonna place it here, and then the spool holder locks in like that. And so now with the spool on there, if you picture that, we're unspooling the filament directly in a straight line, kind of right into the filament runout sensor. So that's nice. And then for storage, it folds more flat-ish. We're kind of contending with this bundle of wires here. But I can fit this in a more compact space when I'm not using it, I guess. I would have to take my roll of filament off, obviously. But I'll just leave it out like this for now. And last but not least, the handle. While it seems kind of trivial, you're probably used to grabbing your machine like this, with the belt here and everything, it's maybe not a bad idea. Hey, it's nice to have, I'll take it. So this is going to bolt in there, and we're going to use T-nuts and these silver screws, the only 2 screws that we have left, to attach that. So the way that I'll do these things is I'll drop the screw in, luckily get it through the hole here. There we go. And then just loosely tighten on the hammer nut or T-nut, and then slide them in the slot on the top. And luckily we can kind of look down the channel and see that they rotate and engage the rail. And if it doesn't, just loosen it and then quickly spin it tight, and it should rotate the nut. There we go. All right. It's all good and tight. So that's a much nicer way to carry the machine around. Well, now that we're done assembling, let's just start taking some stuff apart. Curiosity gets the best of me sometimes, and I want to show you the hot end assembly and the ABL sensor. There's just 2 screws that kind of attach the shroud to the X carriage here. So with those 2 screws removed and the shroud dangling here, so you can see we have the hot end cooling fan. This is blowing through the heatsink, the red piece there with Creality on it. And what's interesting is it's actually got 2 complete slots through the heatsink. It's kind of a unique design. The heater block is still attached to the heatsink with 2 bolts, so it won't actually spin like a V6 would, for example. So it's not as critical that you hold the heat block while you're, say, undoing the nozzle. You should be able to just do it on its own. And they've got a silicone boot here on top of the nozzle. The nozzle is interesting. It looks similar to an MK8, but it's a much pointier little tip, a lot more tapered. And this boot fits that very, very nicely, very little exposed. They're using a cartridge style thermistor instead of the bead, or it might be a bead in the hole. Either way, they're not using the pinch type thermistor that's on the outside, kind of pinched with a screw. It's inside the heater block. Heater cartridge in the front, of course. Here's our little optical bed leveling sensor, and then the daughter board that we plugged into earlier. The cooling fan for the part cooling fan, rather, has a injection molded, not 3D printed, little duct that should direct the air quite nicely right to the tip. All right, so that's reattached. Before we do any printing, of course, you want to make sure that everything's nice and snug. So just since we're playing with the hot end here, it rolls nicely. Actually, there's a little bit of a notch. So you can kind of see that hopefully on camera there. As I move it, it gets caught. So that's indicative of the wheels being too tight, and you can actually have a flat spot on the wheel. Likewise, I've seen a printer after it's been used a bunch. If some debris was on the track and your wheel rolled over it, your wheel could actually have like a chunk missing, a detent, anything that makes it not roll smoothly. In this case, being that the wheels are new, it's likely just that the eccentric nut is too tight and it's caused that flat spot. That flat spot may go away over time, and it may actually not present itself at all once we loosen the bottom bolt a little bit. So let's take care of that before we go any further. So on the back here, 3 wheels. These 2 are fixed. This bottom one has an eccentric nut. We're going to use our included wrench. And if you grab between the wheel and the X carriage there, you got to kind of figure out which way is loose. There we go. So I've loosened it. We can see all kinds of play here. That's obviously not good. So we'll tighten it back up a little bit until things are nice and secure. And then when we roll it, look at that. No more dead spot. And likewise, another way to check is if to make sure you have enough tension, you don't want it to be too loose, is if I spin any one of the wheels here, it should kind of pull itself down the track. And you can see I'm spinning the wheel and nothing's happening. So it's just a little bit on the loose side still. A lot of this goes by feel, so it's kind of hard to describe. There we go. So now we can see it drives itself if I spin any one of these wheels. Perfect, no slop, we're good. We also smooth motion. You'll notice that I'm moving very slowly because if you kind of slide this back and forth, you can induce voltage backwards through the motor, it becomes a generator, and into the board, into the stepper drivers. Just don't do that. So whenever you're moving the printer manually, move it slowly. If you want to be extra cautious, you can actually disconnect the stepper motors from their cables so that there's no chance of that voltage making it back to the main board. Okay, we'll also check the same thing with the bed. I'm less concerned because it was installed at the factory, so they've done a proper job making sure those are tensioned. There's no play, there's no slop. Moving it back and forth, there's no indents, it moves smoothly, so that's fine. If there were the same type of issue that we experienced here, you would just loosen the eccentric nuts. I think they're both on the same side. Yeah, they're both on the same side. So you've got 2 wheels on either side. Yep, 2 wheels on either side. So you have 2 eccentric nuts on this side that you could loosen or tighten as necessary to make sure that this has no play, but is also moving smoothly. So a couple more notable features that Creality has mentioned in their kind of highlights is, put this carefully on its side. It's a little precarious. We are leaning on the screen. Is the power supply that they've used is a brand name power supply, and it's voltage adjustable. So by brand name, I'm going to assume that it's a Meanwell, but we'll find out. And the stepper drivers that I mentioned a little bit ago about not moving things quickly, they're Trinamic stepper drivers, which we've all come to know and love. I'm not sure if they're 2208s or 2209s, but let's take a look at both the main board and the power supply. Now the main board and power supply in this case have the fans on the bottom, so the cooling intake is on the bottom. And on something like the Ender 3, people used to print little shrouds to kind of protect the fan from debris, falling off your printer, little shards of filament getting caught in your fan and whatnot. So that's no longer an issue since they're on the bottom. And they've got pretty beefy legs here to provide adequate ventilation on the bottom so that those fans are able to get fresh air to the board and to the power supply as necessary. Okay, after a pile of screws, we've got this off. There's actually a mesh little filter here to stop anything from getting in the fan, which is kind of nice. And under here, yes, we have a Meanwell 350 watt, 24 volt power supply. And the voltage adjustable feature is done by this little potentiometer right here. stick a screwdriver in him, and turning him, clockwise increases and counterclockwise decreases typically. But you would move it tiny amounts, and you would check the negative and positive with your voltmeter to see what the voltage is at. It's designed to be 24 volts, but there's definitely some play in that value. Increasing the voltage obviously increases wear and tear on components, but can also speed up, the bed heater time, for example. So for the control box, we have one long screw, 2, 3, these ones are short, and then on the top, you'll notice it's like, it almost comes off, but not quite. On the top here, we have one more screw towards the front, near the Y-axis rail. There we go. And then being careful, you've got the cooling fan, beefy cooling fan, and you've got that mesh material filtering all the inlets on here. And we have the control board. So we have a couple unused ports in here. We've got fan 1, which is this one right here. We've also got fan 2, which is unused, and a couple other connectors here. But this is a Creality version 4.5.2 board. Here's our stepper drivers. They've got thermal paste or glue attaching the heat sinks to them. So I can't tell you by looking there, but I'll refer to the manual and see if it tells us if it's 2208s or 2209s. Either way, they're going to be silent. And we have a 32-bit ARM processor, so we're no longer in the realm of 8-bit boards anymore. So that's really all there is to see. We also have a fuse here. There might be 2 fuses. Nope, just one. So we have one, looks like 15 amp fuse on here. So if for some reason, you've got power to the inlet on the side of the machine and no power to anything else, we'll check our power supply voltage, make sure that's right. But you might want to check that you didn't blow a fuse. So let's reassemble this. Here's the little tab that we bolt through from the top side. And we'll just button it back up. Okay, so we're going to go to prepare and move and auto home. Nice and quiet. You don't really hear anything. Tiny, tiny bit of that front fan. So we've homed X, we've homed Y at the back, and then you can see it's using Z-Safe homing. Z-Safe homing homes in the center of the bed or in a predefined position that's not the front corner. And it's designed so that your probe, whatever you're using for your auto bed leveling or Z end stop probe, is in the middle of the bed, or at least on the bed surface for sure, and not off the side here, resulting in a crash. Since we're still using a stationary optical end stop for our Z end stop purposes, we don't necessarily need to have it homing in the center because it makes no difference to where this is. But regardless, it's on, and that's why it's in the center. We can see that it homed just touching the bed a little bit and then backed off. And so it's probably like, you can see it's 0.2 millimeters above the surface right now. And so let's go and heat it up. And at the bottom here, we'll see that the nozzle is set to 200 degrees, currently at 26 or so, and the bed is set to 60, currently at 25. And right now it says the Z is at 0.2, so that's where it zeroed out. And this is the speed, I believe, at 100%, but we're not printing anything right now. So let's wait a couple seconds for this to heat up, and then we'll do an auto bed level. So now we're up to temperature. We're going to go back to the main screen and obviously level, and then we will hit auto leveling. And now we can see that it's going to probe all of these different areas of the bed one by one, and the probe will account for anything that is out of level with the bed as a whole, but also any variance in our print surface thickness, it would account for that. And it will build that mesh, kind of a topographical mesh of that, and store that in memory. And then as it's moving the nozzle around printing those first few layers, it will be able to kind of account for any dips or humps in the print surface or any kind of cantering there is. All right, so it's done the probing and it returned back to the center. So now I can load in my favorite filament, or the sample spool that it came with. The sample spool says 195 to 220, so choose something in the middle there maybe. And I would assume that the SD card has a couple sample prints on it, pre-sliced at the factory. We might print some of those. We might slice something up ourselves. So we'll be right back and we'll show you what comes out of this machine. All right, a few days later and we're back. I think we have about 3 solid days worth of prints here. We'll start with this one. So this is a organic kind of haunted tree type model. One of the guys in the shop here actually does organic modeling and he created this one. So aside from this one, all the links for these will be in the description below. And this turned out great. The only thing that I would comment on this one is we had a little bit of wisping between some of the branches here. So we could dial in our retraction settings maybe. But you know, take a lighter to that and those just disappear like that. We've got no clogs or anything. I'm very happy with how it turned out, and it's pretty cool. I mean, the tree's even got like these teeth things going on. You know, very festive Halloween season, right? So there's that one. And then we have a pine cone. I think it's a pine cone. I'm not sure. I didn't print any of these myself. The guys in the shop here did. But I mean, turned out fine. Looks like a pine cone, it's prickly. Again, minor wisping between some of the tips. So much like the last one, a little bit of dialing in could be done there. And we'll just finish the last black one here. It's a stylized little pumpkin thing with a face. I'm sure that's exactly what it's called. Actually, it reminds me almost of like a Jack Skellington face mixed with a pumpkin. But it turned out fantastic. You know, we used random start and stop points, so you don't have a zipper where all the start and stops for each layer is lined up. So you will see little blips where those start and stop points are. You can dial that in more and more as you go to reduce the visibility of them. But that looks great. I'm very, very happy with how this one turned out. And then these two, this is a bronze filament. Now it's unclear if there's actually particulate, like if it's a filled filament or not. I'd have to look at the spec sheet on that particular filament because we did have a small micro clog here, like an intermittent clog. So that's what that looks like, is where there's almost a gap, but there's little sputters of filament coming out in that gap section. And I think that happened in 2 separate spots, also a little bit on his neck. But aside from that, it turned out fantastic. The shell here is all nice and smooth, the layers stacked beautifully. And it's got an interesting kind of color tone to it. But this one didn't have the wisping, at least not to the same degree as that black filament did. But again, there's just a little bit between some of these points here. And then this last one, this one was about 13 hours or so. All of these were printed at 0.2 millimeter layer height. This one happens to be 10% infill, so it's pretty, so it's pretty light, pretty hollow. And this one turned out great. We didn't have any major micro clogs along this one, so that's good to see. And the layers stacked nicely. There's no Z banding or anything like that. So I would call this a success. As always, you know, there tends to be room for improvement, and some of this is just us dialing in our settings, especially with the filaments that we're less familiar with and kind of experimenting with. So hopefully you found all that useful. Remember to like and subscribe and ring the bell to get notified when we upload more videos like this. Thanks for watching.